Today we're looking at the problem minimum length of string after operations, which was question 2 in Biweekly Contest 135. So this question reads that we're given a string s. We can perform the following process on s any number of times. So we're going to choose an index I in the string such that there is one character to the left of this index and one character to the right of this index that equal that character. For example, let's say we're looking at this A right here in index 2. We can only do this process if there is an index to the left of 2 and to the right of 2 where all three of these characters are equal. So you can see here, index 2 is A, 0 is A, and 3 is A, so we can perform this operation here. And what we do is we're going to take the closest index to that character we're looking at that are equal and delete those. So in this case, we'd be looking at index 2, so we would delete 0 and we would delete 3 and be left with just that A at index 2. So what we want to do is we want to return the minimum length of the string we can achieve by doing this operation. So let's look at this example here. We see that we have A, B, A, C, B, C, B, B. So the first time we can choose index 2 like we just talked about, and we're going to remove the A at index 0 and also at index 3. And this is going to leave us with just one A left over. Then in the next process, we're going to choose index 3 and remove the characters at 0 and 5, leaving us with this final string ACBCB. And what we're going to do is return that 5 because we want to return the length of the minimum string that we can achieve. So let's look a little closer at an example and see how this works. So in the problem, it says we want to delete the closest indices to whatever character we're looking at. So let's say we're looking at I is 2 here. According to the problem statement, we actually want to delete 0 and 2. But this is a little bit misleading, and we don't actually have to worry about this. So let's look at another example. Let's say we just had 5 A's here. So what we choose doesn't actually make a difference, right? So let's say we're looking at this A right here at index 1. We can either delete anything to the left or anything to the right. So let's say that we deleted this A and this A. So here we're still left with 3 A's, right? We could then go to this A and we could do the same operation on these two. Or we could have initially picked this A to delete. Well, again, we still have 3 A's, right, that we can then continue this process on. Similarly, if we picked at index 2, we're still left with 3 A's. So really, the position doesn't matter, and this is a bit of a misleading thing to trick you in the description. What we really care about here is more so the count of each character. Because as you can see here, the A that we pick doesn't actually make a difference. All that matters is that we have a certain number of that character left over to process that operation on. So how do we know that we can do this operation? Well, remember, we said we have to have, if we have a character, one on the left and one on the right, and we can remove these. So as long as we have greater than 2 of the character, right, we can perform this operation. And we don't have to worry about where they lie in the string. We know that by its nature, a string goes from left to right. So if we have 3 characters, there must be at least one occurrence where we have that character with one on the left and one on the right. So we're not actually concerned with position here. What we want to do is think of the counts of characters. So let's keep track of our counts in a hash map. So you can see here, we have 1, 2, 3 A's. So we'll say A is 3. Here we have 1, 2, 3, 4 B's. So B is 4. And then we have 2 C's, right? So now that we have these counts, what can we do? So let's go through these counts and actually apply the operation. Remember, we said we don't care about the positions. All we care about is the count, because here you can see if we have 3 A's, we know that there must be this kind of configuration somewhere, right, that we can reliably remove. So let's do that. We see when we do this, we actually are removing 2 characters. So we can say, while the character is greater than 2, while we have more than 2 of them, we know that we can perform this operation. So let's do that. So we then decrease this to 1. And why do we do that? Because we're essentially performing this operation on A, and saying, we've now gone from 3 A's to 1 A. So now here, is this greater than 2? It is not, so let's move on to our next character. So here we have 4 B's. So likewise, we know that since we have greater than 2, we know that there's at least one configuration like this somewhere in the string. So we know that here again, we can remove 2 characters, right? So we remove 2 B's here, and then we come to C. So when we're at C, we say, is this greater than 2? It's not, so we just don't do anything. Our final count is 2. So as you can see, if we add all these up, this is equal to 5, our answer. So essentially, what we're doing here is ignoring positions, ignoring the actual layout of the string, just getting the count of all the characters and using that information in order to figure out what the smallest possible string that we can create is. And we do this in O of n time, right? Because we are going through this string one time in O of n time. Technically, there are 26 keys we can go through, so we can do O of n plus O of 26, but we don't count constants in our big O complexity, so it's going to be a final result of O of n. So let's hop over into the code and see exactly how this will work. So the first thing we're going to do here is we're just going to import a counter. This is just a very simple way in Python to get counts of a certain string or array. So we're going to get the counts of all the characters that are in that string. Then what we're going to do is we're going to iterate through each key and value in that dictionary that we make. We're going to set this new count variable, and what this does, this is going to represent the final count of the characters after we perform this operation some number of times. So we're going to use that condition. While the count is greater than 2, we know that we can perform an operation and get rid of 2 characters. So while this is true, we're just going to decrement this by 2, which represents getting rid of 2 of those characters. Then once we get out of this loop, it means that we can no longer do that operation. So what we're going to do, we're just going to update the counts of that character with the final value that we've gotten. Then at the end, we're just going to take those values that we've had after doing this process and sum them up and return them. So let's submit this and make sure that it works. And it does. So hopefully this made sense and was helpful, and thank you for watching.